Steven said voice football.
Steven, you're not helping.
Chunky phlegm ball that was moist.
It's
getting worse.
Okay.
I can't write, sorry.
Yeah. That's a little excessive. Almost as excessive as.
No, I don't want to hear it.
Do it.
No.
Do it.
Change story.
I'm not saying anything.
We should find the acceleration of this.
Oh, we probably could. We need a model. Can somebody model that?
Well, Shane's 6, you're like,
Sid, stop.
I don't know what's happening, but I don't think I remember what's happening. Sydney just found a felt like
I claim it.
What's the matter, Johnny? What's disgusting?
Yes, like, yes.
Not Steven.
I like meant to say Johnny and then Steven doing it.
He's like, yep, no.
What's a heart rate?
You scored.
Don't work there.
And a bunch of.
Hey,
My daughter did.
Your daughter started.
well, it's federalized. His daughter, no, Sydney.
Alright, let's focus here. We had a little bit of fun. Now we're going to have no more fun the rest of the time.
That was not.
It was extremely fun. Okay, so now we're going to focus. We're going to have the maturity level of actual human beings that have somewhat mature. Okay, so we're going to focus here on acceleration. You probably have heard this word. You probably use it actually in your vocabulary a few times a year. Okay, so you probably know a little bit about what acceleration is. Okay, so acceleration is an increase in velocity over a certain time period. Deceleration is a decrease in velocity over a time period. Now, listen to me very carefully. Deceleration does not mean negative. And acceleration does not mean positive. Because you could have a positive deceleration and you could have a negative acceleration. Okay? So this isn't quite as simple as the directions like you would for position or velocity, because acceleration depends on your velocity. So, here's your formula. Now, you can replace acceleration with what its symbol is. What do you think acceleration symbol is? So your equation would be A equals change in V over T. Or another way you could write it, what does change in mean? When we do change in, now how do we do it? Final minus initial. Okay, that's important to know. So V final minus V initial. Those are the same equations, just one is simplified more. Well, usually they just give you the change in time and not two different times. So I usually just write it as T. Technically it should be change in T, but it confuses students when they only see one time number. Like, how is there a change in this? Well, they gave it to you. So then we should probably fill this vocabulary word in or put it in the back of your notebook somewhere. The name is acceleration. The variable symbol is what? And here is your most common unit. Second squared, yes, it is. I'm going to leave that blank because it's a little bit more complicated than just saying vector quantity. Because you have to know a couple of things to be able to know the direction. Like I said, because you could have a negative acceleration and you'd be going in the positive direction. That just means you're slowing down. You could have a positive acceleration even though you're decelerating, which means you're going in the negative direction. And you'll learn that if you take physics. Okay? Quick review. Raise your hand if you know one of the variables we've talked about up to this point. Go ahead. Displacement. Could you tell me what the most common units are? Meters? Okay. Is it a vector or scalar quantity? Good. Somebody else. A new one. Stevie? Distance?
Meters per second.
Nope. Distance is d. What's its unit though? It's not meters per second. Meter, right? A distance is always in a meter. Okay? Vector or scalar? Scalar. Okay? Something new. Ethan?
Acceleration.
Acceleration. Okay, fine. Okay, you got that one. Something else. Sid?
Time,
Time?
T,
Okay?
and second.
Seconds. And there's really no vector scalar for that guy. Another one. Somebody else. Now we're getting to like the harder stuff. Yes. Speed. S. Meters per second and scalar. Good job. One more? One more, right? One more. Velocity is V. Meters per second and vector. Okay? Fill in this. Displacement is to velocity as distance is to speed. Okay. Good review. I might just throw a pop quiz at you one of these days where you'll have to know that. Just be warned. Know all the unit stuff, not just that one thing I said. There's my warning. You guys know what pop quiz is, right?
Yeah, like when they use second quiz.
Yeah. Be ready for that.
It's just like pop.
Like pop, there it is. Okay, so this is just showing kind of what I had you write down. Okay, it says the units of velocity are a distance over a time. That makes sense because velocity's common unit was what? Meters per second, and distance is in meters, and time is in seconds, so it makes sense that velocity is distance divided by time. Okay? Then it says acceleration is velocity divided by time. So velocity is a meter per second, and you're dividing that by time as well. So it's really a distance divided by time twice, or another way of saying that is the time squared there. Okay? So. just kind of rewriting in your notes so you have it. So after it's been a few days and it's not fresh in your memory, you can go back and look at it. Okay? That visual is only showing you how the negative sign doesn't always tell you direction. Okay? For example, what do you do when you come to a stoplight? What happens? You what? You come to a stop, right? So that would be decelerating, right? Okay? Well, notice how your acceleration is actually in the negative direction. You would actually get, mathematically, you would get a negative acceleration. But you're going in the positive direction. Does everybody see that? So, the sign of acceleration in this context doesn't directly tell you the direction. There's a few other things you would have to know to be able to figure out the direction, which I'm not going to make you do in this class. It's a little higher level than that, than where you're at now. Okay? Getting close to a problem here, I think. Hey, guess what? Go ahead and put this in your notes. And we'll tackle it. Everybody got it written down? Okay. What did I say the very, very first thing you should do when doing a math problem is? Write out your variables, okay? Label your variables, okay? What is the first thing you should look at to figure out what your labels are? What tells you what the label is? What did I say? Because not always does it say the time is. What tells you what the variable is? Really important thing. Right here, what Ethan said? The units tell you what the variable is. If I say 15 seconds, what's the variable? If I say 12 meters, what could the variables be? Or displacement. Why can it be one or the other? They both have the same unit. So how would you distinguish then between whether it was distance or displacement if they have the same unit? Direction. Everybody hear what he said? Because we know distance and displacement both have the same unit. So the only way to tell the difference between distance and displacement would be to look at the direction. So, what is that? Why is it displacement? Because it's a vector quantity which has a direction and magnitude. What is magnitude? Amount. Lots of vocab, isn't there? All right, let's label. Car is moving at 5.0 meters per second smoothly, accelerates to 20 meters per second in 5 seconds. Calculate the car's acceleration. North is positive. Okay. Anybody got an idea what a variable we have up here is? Rose? Velocity, okay. So just V. Well, which one is it? That's the the initial velocity. Everybody see why that's the initial velocity and not just v? Why is that the initial velocity? Context of the problem, right? Not only is context key in biblical reading, but context is key in physics reading too. Okay? It says a car moving at 5.0 meters per second, look at that unit, smoothly accelerates to another velocity unit. Everybody see it? Two velocities. That usually means you've got an initial and you have a final. Finally, you get to there. Initially, you started there. So VI is 5.0 meters per second. And I probably should put a positive sign there. A better way to do that would be just to say 5 meters what? Meters per second what? North. And why is it north and not east? Because they told us the direction there. Okay? What is the 20.0 meters per second? Final velocity. Okay? And what's the other variable they gave us? Time. Everett, what are we solving for? You sure? Acceleration. All right. Let's plug in. Now, why would I use this equation?
Because we have both of finite.
Yeah. Now, could they have said the change in velocity is this? They could have done that, but since they actually gave us two different velocities, we have to break it down and use this one. So, let's do it. Now, remember that we are taking and we're substituting in the number for its appropriate variable. Okay? So, I'm going to substitute VF in with the number. So, VF is 20. I'm going to put parentheses around it just to show that. Minus my VI equals 5. So I'm going to put 5 in for VI. All over the time, which is what? Now, is the variable that we want to solve for by itself?
Yes.
Is it on top of the fraction?
Yes.
So, what do we do? Just solve it. Everybody got your calculators? You get to use your phone on a test. Alright, everybody, pop these into your calculator. I agree. It's not so easy for everybody. I know.
You don't have to have
You don't have to. Yes, Mari?
No, it's mandatory that we go through all of the steps.
Oh, I cleared it.
It's mandatory that you do this. It's highly suggested that you do this. Anyone know why this is highly suggested? What if you didn't show your work and you got the problem wrong? How would me as the teacher that has to grade it know what you did? How do I know if you just flat out guessed? Or if you plugged it in your calculator wrong and like switched a number? Will I know the difference? No. So I have to assume that you did the worst of the two. And so you will get most of it wrong if you do not show your work. Even if you had a little brain fart or your finger pushed 2 buttons on the calculator instead of 1, you didn't know it. Okay? Please. You don't have to do this, but it's highly recommended. Does that answer your question, Marty? Sure. Didn't say you like the answer, but that answer. Questions on this? Wait, did I give you the answer? No. What'd you guys get? 3 meters per second squared. Whoops, I put the number in there. No. I still do want to put the direction. Even though technically it's not a vector. Get in the habit of doing that. Anybody not know why we put the numbers the way we put them, or not know how we got 3? Now's the time to ask. 20 minus 5 is what? 15 divided by 3 is? By 5 is? 3. Okay, sorry.
Oh my word.
Yes. Hey, you guys solved this one.
Oh man.
And I'm going to make up a more difficult one and we'll do it together. This one's not so bad. When you have an answer, raise your hand. Don't get old. Don't ever get old. First step, label your variables. Look at the units. The fact that it says east is positive should tell you that you're dealing with vector quantities. Hold on. Right now? Okay. That was for you. No one done yet? Done? This your work wrong. Final minus addition. Yes.
Yeah. No.
Okay. You have all your variables correct here, but you plugged them in wrong. Final minus initial. Well,
You don't have a negative in your hand.
except that I would have. It's a poorly worded question. It doesn't actually tell you you're heading west or east. If it said you were heading east, then that's definitely true. But yeah, I wish it would have. Now that I look up there, that's kind of because it should tell you exactly what you're heading. Yeah, I'll explain in a sec. I'm not so worried about different.
Yeah, I think so. That's right.
That's what he's saying. It's not really, so we can assume that it's going east, but it's not like, it doesn't say. So
It's final minus initial. Yep.
Am I right now?
Yeah, I'll accept that. I'm going to tell you why there was some faultiness to the You mean you just kind of guessed? Stop, Mari. Okay, so you have the right, yep, that's the initial, that's the final. Stop it, Mari.
That's so weird. That's so weird.
This is final minus initial. So you put the initial in the final. Does that make sense? I'm about to. Do that again.
It's a merit.
I have it.
Alright, I want to show you, because technically there's a little fault in this problem. Okay, so let's work through this together. Okay, we should have a VI, a VF, and a T. Okay, I think everybody got the labels correctly. They had your initial being 20, and your final being 0. I did see this a couple times, where you plugged in the initial into the final portion. So I did see a couple 20 minus zeros. Okay? Be very careful because it will give you the same number, but it will give you the wrong sign. Okay? So be very careful on this. Now, where is the black? When you plug this in, you should get 0 minus 20. Divided by 6, which would give you a negative 3.3 repeating. Now, here's the faulty part of this problem, is it says that east is positive, but it didn't actually say you were heading east. Okay? If you were heading east, you would put east. Why is it not west if you're heading east? Think you know?
I think I know.
Okay, what do you think?
Because you're getting slower, so it's.
So you're slowing down, hence you're negative, but you're still going east. Right? Does that make sense? So this is where I said it's important to note that the sign of acceleration does not tell you the direction. The direction is going to come from the context of the problem. Okay? And again, all I want you to know is if you're doing acceleration problems, I would just stick with the sign they give you. Don't try to throw on a direction based on the sign because it isn't that simple. You don't know, because if you're speeding up and slowing down, that also determines what the sign is along with the direction you're traveling. So it's more complicated. Okay? Now, we only have 2 more minutes. I was going to make up another problem. If I gave you acceleration and gave you your initial and your final velocities and asked you to solve for time, why is that more difficult? Thank you for making that connection. Time is on the bottom. What did we say was important for every time you're solving for a variable? There are two things that have to be true. Alone and on top. Okay? And there are a variety of ways that you can do this. I said take the reciprocal would be one way. Cross multiplication would be another way. Like taking whatever time is, or taking A and timesing T, and then taking 1 and timesing that. Let me show you an example of this. Okay, you've learned this before. I don't know if you're learning, have you learned any time in the near past? Nothing? In the most recent past? Well, there could be a far past and near past, right?
Yeah.
Okay. All right, let me quickly show you the cross multiplication method just for you to review. Okay? You would take x and times 4, that would give you 4x, correct? And then 2 times 7. And then you could solve just like normal. Do you see how x is now on top? Yes, that's another method to getting something off the bottom of a fraction. Okay?
Going to the game.
Can you get it from somebody next to you?
87, 6, 7, 9, 11.
Everett, listen to.
Page 87, number 6, 7, 9.
Oh, I was there and I didn't get it and you all did. But I would say, I'm better than you. Okay, no, oh, same, that happened to me. Yeah. After church.
The vocabulary is more.
So I had the green arrow and he just came speeding through and I was like, stupid. Yeah, I was like,
I do.
I'm out for lunch.
yeah, more.
Mario,
I don't know if that's